So here in this lecture we are going to talk about angular momentum. So let's take that there is some particle like that, and it is placed in a coordinate system like this. Here is x-axis, y-axis and z-axis, and then it is having a velocity v vector in some direction like this, and the position vector of this particle with respect to the origin is r vector. Then we define a quantity called as angular momentum, which is analogous to the momentum in the linear motion. Here we are talking about the rotational motion. So in rotational motion, we define a quantity similar like the momentum called as angular momentum. So angular momentum L vector is defined as the r vector cross p vector, where p vector is the linear momentum of the particle, and as you know, the linear momentum of the particle is mass times of velocity. Okay. सो यहाँ से हम बोल सकते हैं कि एंगुलर मोमेंटम हो जाएगा अपने पास में आर वेक्टर टाइम्स ऑफ एम वी वेक्टर, करेक्ट. सो एल वेक्टर यहाँ से हो जाएगा एम आर वेक्टर क्रॉस वी वेक्टर, और अदरवाइज एल इक्वल्स टू एम वी आर कोस थीटा. यहाँ पे थीटा एंगल है बिटवीन आर वेक्टर एंड दी वी वेक्टर. जैसे इस डायग्राम में इस पॉइंट को हम थीटा ले सकते हैं. ओके, नाउ दिस formula we can apply when we have a point mass. What if we have a rigid body? Okay, instead of the point mass, let's suppose we have a rigid body like this. Okay, this rigid body is rotating about somewhere about this axis. All right, about this axis it is rotating with omega. And let's suppose the moment of inertia about this axis is given as, okay, x, y and z. Moment of inertia about y axis is I. Okay, so in this case we define the angular momentum of the rigid body like this. The angular momentum will be I times of omega vector. Okay, ये तब हम यूज करते हैं जब कोई एक रिजिड बॉडी प्योरली रोटेशनल मोशन कर रहा हो. ओके, इस एक्सिस के अबाउट ये अपने पास में फिक्स्ड एक्सिस है. ओके, एंड तब अपने पास में हो जाएगा एल एंगुलर मोमेंटम इज आई. आई इज द मोमेंट ऑफ इनर्शिया अबाउट दिस फिक्स्ड एक्सिस ऑफ रोटेशन, एंड ओमेगा इज एंगुलर वेलोसिटी अबाउट दैट एक्सिस. ओके, नाउ this formula, of course we can derive this formula with the help of this as well. You can take somewhere the point, and then you can take the r vector, then you can find out the velocity vector, and with the help of that you can find out the angular momentum. So these are two formulas. This is first format which you can use for point mass. This is how we define the angular momentum of the point mass, and then we have the angular momentum of rigid body. Of rigid body in rotational motion. Okay, what if let's